The following circuit is from our electronics lab, well, partially. So the first part is our heart rate sensor, this part right here. And then these potentiometers are going to be used to adjust the gain of the actual output and then also adjust the DC offset. If we apply a DC voltage offset, we're going to be able to move our waveform into a more favorable region where we would look at the output. So just to refresh ourselves on this circuit, first we have the analog discovery 2 hooked up to it. Here we have a negative 5 volts and it's going for the power of this op amp. The pinout for this should be in the notes in the description. Then we also have this ground wire, this black wire. This orange wire is going to be grounding the other side of our scope channel that's going to be monitoring. We have this red wire, which is the 5-volt power, and we have our power rail as the plus, our ground rail as the minus. Now, if we look right here, we have our differentiator, I believe, and then we have our infrared LED and then our phototransistor. When we put our finger over it, the blood cells go through the finger, the infrared bounces off, the phototransistor detects that, and it sends that through the rest of our circuit. So this is the very beginning part, and it's going to go this way through our circuit. Now, this is part of our op amp right here at the very beginning, and then the second part of our op amp is right here. There's, I believe, like 4 different op amps inside of this single chip. So we have the first one to the left here, and then on the right of it, so like over here, would be another one with this resistor being its input, and then this capacitor going to ground. We have this little circuit right here, can't forget about that. That's tying the last 2 pins together, and this resistor going out here, which is going up here, which I believe is to the negative input of this op amp. And then our 5-volt right here is going directly into the op amp. We also have these wires, which are going to be for the capacitor and resistor. These are in parallel with each other, and I believe this last wire is output. This one right here is a negative input, and then this one right here is a positive input. So if we look at what we've added on from that circuit, we really just added on everything after these 2 wires. So the first thing that we're doing is originally what we had was this wire not connected to our potentiometer. Originally, this right here was our, I believe, positive input. Again, that's in the pinout for this. It could be easily searched. It was originally going to ground like this. And this output was not here. We would just take our oscilloscope probe, the channel probe, and put it at the output and measure that for our heartbeat. But now we want to actually adjust it. So this is going to go into this right here. So with this potentiometer is going to adjust our DC offset. And what that means is that we have our actual scope channel, our signal, being displayed on the graph. If we want to raise it up, we apply a DC offset. If we want to raise it lower, we just take some of that DC voltage away. So pushing in a DC offset is going to move it up or down. Now, this potentiometer right here is going to be adjusting the gain of our circuit. So adjusting the gain goes straight into our output. If we look at these just by itself, this right here is going into our potentiometer. And then this is the output of our entire circuit. So all of this to the left right here is going to output at this right here. And this is going to go into this potentiometer. And now this node is going to be our output. And so that we were monitoring this. This is our other channel probe. We're monitoring it. So now with the circuit done and looked at, this is what it looks like. Again, there's a lot of previous videos, I think at least about 3, going over this one circuit because we've had a lot of issues with it in the past and now we've figured it out. So now what we're going to do is we are going to look at the actual waveform for it. So for the waveform, there's a few things that we should notice. The first is that our mode needs to be shift. This can change easily, just select it. For the source, we want that to be a channel 1, and we can have our level just at 1.5 because we want it between 0 and 3, and that's for just this specific project. That's what the DC offset is applying. We want to move it up because originally, if we remember the circuit, it was between about negative 3.7 and about positive 3.7. We don't want the negative voltage values for our project, so we're shifting it up. So now from here, what we're going to be doing is we need our maximum and minimum. so that we know that the minimum is above 0 and the maximum is less than 3.3 volts, because what we are going to be plugging it into is this STM board, right? So this should be going into our circuit, and that'll be explained more after this first part, which is just testing it. So from here, we are going to display our channel 1. We only need the channel 1. We'll have our base as 1 second per division. That way we can see a lot of these waveforms. We have our average as 200, and everything else is a little bit default. We don't need our wave gen. Our supplies are going to be 5 volts and negative 5 volts. And now we can look back at our scope. So for this scope here, again, we need to look at our maximum minimum. What I'm going to do is play our supplies and then play our scope. So now we have some signal coming out. We see it starts out at 5 volts and then it's going to trail down. This is completely normal. Once it trails down, all that I'm going to do is put my finger over this. We can see that if I just swipe over it like this, it's going to give us some signal. So I'm swiping over it, and that's because the phototransistor is detecting the light bouncing off the infrared. So, or is bouncing off my finger. So you can kind of see it in the monitor screen, but now I'm just going to take my finger and I'm going to place it on here. Once I do that, we are going to get this. So we can see it's going to normalize into an actual heartbeat. Now it's going a little bit below 0. I'm going to actually adjust my finger. The best way that I found out to do this is I'm going to put this against my laptop and put my finger across both of them like this. So with this done, we can look at our circuit again. It's going to look like this, and it's important to keep the finger steady throughout the entire process. If you get any error, just reposition your finger. It can be a little bit finicky. So I'm just moving my finger around a little bit. Now I'm going to stop moving it because it looks like we have a nice waveform. So it seems like, again, there's still a lot of noise. We can see that with the right hand side. And just adjusting my finger a little bit more, we get the following here. Now we can see that our result is above 0 and it's lower than 2. Now what I'm going to want to do is adjust my potentiometers just a little bit. If I were to adjust the top one, so this one right here, we can see it move. So I'm not going to be able to see both at the exact same time, but looking at the waveform, I'm going to move the potentiometer to the right. Moving it to the right, you can see the waveform gets super small. Now let's move it to the left. So now it's growing a little bit more. We can look at our maximum and minimum. Now it's still between 0 and 3 volts, so this is good. This is what we want. We can leave it just like this. We can see how I've moved it. The little dial has moved up this way. And we can also adjust the bottom potentiometer just by taking something like this. It comes with the parts kit, and putting it inside of here and moving it around to adjust for the voltage or the DC offset that we would like. Because we're applying a DC offset to what this would be ground, so we're just going to be adjusting that, applying more or less of a DC offset. But we don't need to because it looked perfect. And so that was the waveform, and that was this circuit. What we did not get to work was the following. So we would have our Nucleo board right here. It takes a micro USB input. We would place it into our board right here. We would provide power and ground because this board can provide power and ground. We would ground the wires, and then we would also give power to the circuit. So we would, instead of having this analog discovery right here, what we would be doing is first we want to pause our scope and supplies for analog discovery. So I'll go in the software and do that right now. But what we would want to do is we would take out these wires. We don't need them anymore because we would just be using these and applying this here. Now this negative 5 volts, I believe we can also power it from this board as well. If not, we would have found a workaround for it. And then we would be connecting this output. So taking out the probe that's monitoring it, because we don't need to monitor it anymore, we would take out the output and we would connect it to one of these pins and set the pins as output in the actual program itself, the STM32 program. Now we couldn't get everything to work, and there was a problem with that. The problem again was that we just didn't have enough time. It was a little bit more challenging than what we thought it would be. The circuit works good. Individually, the codes, except for the peak detector algorithm, work fine as well. Again, the only problem is that we just couldn't get the actual output to go here and then work with the peak detector algorithm to get those values. We really barely even tried that. So now looking at this, we have our presentation. This can be found in the description, link below the like button. We also have a video just going over everything that we've done. So it's going to be this one right here. It's just going over the slides and giving some more information. We also have this Google Docs, and this Google Docs gives responsibilities, more information about each of the things that we had to do, our test cases as well, and it provides a conclusion and references that we used for this report. All in all, if we had more time dedicated to this, we probably would have gotten it done. We also had trouble implementing our finite state machine with the peak detector algorithm to the rest of the code. But the other parts, as well as the heart rate sensor, worked. It was just the peak detector algorithm that was a little bit troubling, and that troubled the rest of the report. The last thing is our Bitbucket project right here. We had a lot of testing that we did, and then we also have our finite state machine right here. In our finite state machine, our main.io was the main file that we had everything inside of. So our main.io included our peak detector, which was used from the Pan-Tompkins algorithm. This was got off a website that we found. Didn't really have time to modify it, so we weren't sure if it worked 100%. But again, looking back at our code, we have that implemented in here, as well as the other parts of our code. Now, without the main.io, if we were just looking at the main.c for our FSM, it includes everything except for the peak detector. And this part is what worked by itself, just not with any real world data. It worked with a testing sine wave data. But that's it for this project and how we went about it.